Okay, killing time. All right, here we go. Don Wegeng, one of our, you've been a member, what, 3 years, 4 years? 3 or 4 years? Yeah. Okay. All right. Well, Don, I hand the mic to you. You can take it away and give us a Meshtastic overview.
We'll try. Everybody hear me okay? You know, before I retired, I used to give presentations, but I never had to talk into a microphone. So if I go, holler at me. Okay. So I got a couple. Let me see if I can figure this out. I want to advance. I go that way. No, that way. Okay. Okay. Very good. So before we start first, okay, I'm Don Wegeng, KD2WWY. I got licensed during the pandemic. I started playing around with Meshtastic last summer. I got kind of curious. I saw some YouTube videos. I said, what is this thing? And I had some use case in mind, which is maybe not the one most people in the room would think of. But before I really get started on that, let me ask a question. Just raise your hand. How many people have heard of Meshtastic before? Most of the room. Okay. How many of you have a Meshtastic node? How many of you did you bring one tonight? Did anybody bring them? Could you hold it up if you brought it? Just because I'm not going to put you on the spot, but just to look around so you can kind of see. That's what the nodes are like. You know, they're not, as big as an HT or, for the most part. They're very small. A lot of them don't cost very much. But just I wanted to give you a feel for what is, just so you know, what are we talking about here? But it's called Meshtastic. It was I think it was first introduced as an open source project back in, I think, 2019. And it kind of grew for a little bit, but it was really something that really didn't, it really started taking off, I think, about a year ago. I saw some Google Analytics that kind of showed a flat curve, by year, and then suddenly about a year ago. So, it seemed like something that people are interested in now. Now tonight, my goal tonight is not to focus on a single use case. It's not going to do a incredibly deep dive. What I really want to do is give everybody an idea. What is this? What does it do? How does it work? And what could you do with it? We'll show some. I got some pictures of a few example Meshtastic radios. I'm going to talk a little bit about use cases, but what I really want to do again is I want to focus on what does it do? How does it work? Because I think as you learn those things, maybe you'll get an idea of what you might want to do with it. Or you may look at that and say, I don't have any use for this at all. And that's cool. But just to learn. So that's kind of what I'm doing here today. Okay. And if there's time for you who brought nodes, if you have some time, if you don't have to run right away, maybe we can, if you can, come up, to the front with your node, maybe some folks can informally after the meeting take a look and, you can tell them about them. Okay. Okay. So here we go. So what is Meshtastic? I got like 3 slides on this. So this is kind of a multiple choice question. What is it? It's an open source network for building decentralized communications. It's a low data, long range, low power communications protocol. And I should say, I realized I didn't say this, this is data. There's no voice over Meshtastic, okay? It's an ad hoc decentralized mesh network. You put up a couple nodes and you've got a mesh network. You don't have to have a central server or something like that to manage it. It's encrypted, it's off grid. Again, it's texting and data, pretty much. And it's low cost, and it doesn't require a license to use. You don't have to have an amateur radio license to get into Meshtastic. There is a ham mode that if you want to get into that, but we're not going to really talk about that because honestly, if you put your Meshtastic node in ham mode, you won't be able to talk to anybody else. So not really going to cover that. But what does it do? So what's the big deal? We already have ham radios. We already have cell phones. We already have Wi-Fi. What is this? And it's something that's very good at sending text messages and small amounts of data. It does it very, very well. Now the text messages you can broadcast to all the nodes on your mesh. You can do a direct message just to one node if you want. It can work without any other help, like I was saying before. You don't need the internet. There are ways to connect it to the internet, which honestly I'm not going to talk about tonight. But it doesn't need anything else. You don't need cell towers. You don't need some centralized server to manage it. You put up a couple of nodes, like I said before, and you've got a network. If you don't have cell phone, no problem. You don't have Wi-Fi, no problem. If you're in a very, radio noisy environment, it's very, very good. It can actually, it's kind of like FT8. It can communicate. You can get data below the noise floor. Don't ask me how it works. I don't really know, but honestly. But and then, like I said before, you don't need a license to do this. You can just go buy a node and get out there. Now, if you're going to do that, there's some things you probably want to know about it first, and that's what I'm going to try to cover tonight. Oh, I should say, if you got questions, just ask. I'm going to try to keep going quick here. I got like 30 slides or something in an hour. But if you got a question, just hang up or put your hand up and let me know. Okay? So this is kind of the get down into the noise slide a little bit that I'm not going to go into lots of detail, but there's just some background stuff so you to know. I didn't really have time to get into this, but Meshtastic is open source, and it rides on top of the existing LoRa Internet of Things protocol. So has anybody heard of LoRa before? Long range. It rides on top of that. Now, I'm not going to get into LoRa and get it. I could spend 30 minutes on that, and I'll probably just show how little I know about it. LoRa, L-O-R-A. LoRa. No, Meshtastic rides on top of LoRa. It's a higher level protocol on top of LoRa. And LoRa is it uses spread spectrum. So that's part of how it's immune to noise and interference and things like that. Again, I could probably spend 30 minutes talking about LoRa, and that's not what we want to do here. But that's kind of under the hood, that's how it's working. It's a full mesh network, and I'll get into what is a mesh network here in a minute. But as a network, it does hop to hop, and it can go up to 7 hops deep. It defaults to 3 hops, and I'll explain all that here in a minute. It uses the license-free ISM band. ISM, I think, is industrial, scientific, and medical. So it's really a band that's made for those types of devices. But that is shared spectrum. It's between 902 and 928 megahertz. And oh, by the way, somebody here in the audience is probably going to think, wait, that's the 33 centimeter ham band. And it is. It's shared space. But Meshtastic isn't ham radio. That's why you don't need a license for it. And it can operate, it can tolerate, very noisy environments, and you can operate up to 1 watt without a license in that band. So that's not high power. That's QRP. You can get some pretty good distance on it. It is node to node communication at the basic level, and it's line of sight. 900 megahertz is not going to penetrate a mountain. It's line of sight. So, but by node to node, this is where the mesh comes in. A node to node to node to node, where nodes retransmit. And again, I'm going to get into that in a minute. There's several different modes that it can operate in. The default is something called long fast. And at long fast, you can communicate data at about a kilobit per second. That's not bad. You're not going to be sending lots of photographs and movies and things that way. You can certainly send, sensor data, and you can send text messages and things like that. But that's really what it's designed for. And if the rule of thumb is that if you have three well-positioned nodes, meaning they've got some good line of sight without a lot of obstructions, you could build a mesh just of three nodes that's probably at least 15 miles wide. So, you know, it's got some flexibility there. It does optionally connect to the internet using something called message queuing telemetry transport, MQTT. And you can use that to bridge isolated meshes. I'm not going to talk about MQTT tonight because honestly, I don't understand it that well. And it also isn't what most people want to do with it. But if you're interested in that, you can look that up and learn about it. Okay. Any questions so far? Okay, so this is a mesh. This is just one I drew to kind of talk about. And you can, these lines kind of show which nodes can talk to each other. So it kind of looks like a mesh. I guess that's why they call it that. And basically, you know, the mesh, the nodes don't all have to talk to each other because they're going to do store and forward to get the data further around. So what I wanted to do is kind of talk about this one as a kind of an example to walk you through how the mesh network works. And so in this example, and what I should say, it's using what's known as flooding. So a node sends a message, which is the message gets received by other nodes that then send it out again. And then they send it out again. And then potentially they send it out again. And that way it spreads, you know, in the example I'm going to give, it's going to go from left to right. And that's how the message gets propagated throughout the mesh network. But like I say, this is packet data, not voice, it's data. And let me kind of walk you through an example that I made up to kind of do that. Let's assume that node A, I don't know if you can read my tiny letters there, but this is node A right here. Here, let me use the mouse so that folks online can see it. That's node A. And that's going to send a broadcast message. And it's sending it to all the nodes that it can get to. You know, so it's like somebody who says they want to send out a message and says, you know, there's free water distribution down at the fire station or something like that. So node A sends that message out, and basically that it can talk to two, in this example, it can talk to two other nodes. And again, that just happens to be how the topology of this mesh works. So it gets to node B and it gets to node C. So they both receive it. Now their job is now to say, oh, I think I need to send this out again. And we'll talk through how that works. It's basically going to look at something called a hop limit. Every message in Meshtastic has a hop limit. And that says how many different hops or how many, you know, where from here to here, say, is a hop. And then from here to here is another hop. And then this is another hop. Okay, that makes sense? What's the mouse? Oh, okay. Boy, it is high technology. Sorry. Yeah, I want for the folks online. Yeah, so this is node A. It's originating the message. Going to go. It sends out a broadcast that goes to node B and node C. And I was mentioning there's a thing called a hop limit. So node A, when it sends out the message, there's a hop limit, and by default, that hop limit is 3. So that's designed to keep a message from just bouncing around the network forever. Because when node B and node C receive that message, they decrement the hop limit, and then they say, gee, is it 0 yet? If it's not 0, they're going to try to send out the message again. Now, there's some details going on there that I'll talk about here in a couple of minutes. But just for now, let's say that node B and node C each say, okay, we're going to send out the message again. So in this case, node C sends it out, and the only other node it can send it to is node D. Node B can get it to node E and node D. So node D got it twice. Each one of those two nodes, D and E, again, are going to decrement the hop limit by 1. It's still not 0. So then they're going to send it on. Make sense so far? Okay. Node E sends it to node F, but node F, hey, notice node F got it through an additional hop. So node E didn't have to go through. So now node F decrements the hop limit and says it's 0. Node F says, I'm done. I'm not sending it out anymore. Node E, on the other hand, since it got it through a shorter route, it can send it out one more time, and it sends it over to G. And G now says, okay, I got it. It's going to decrement hop limit. It's going to go to 0. And so node H over here on the right is never going to get the message. Now, I show it like that because I wanted you to think, if you think about how you want to build a mesh network using Meshtastic, you don't want it to be really spread out. You need to have the smallest number of hops as you can. And we can talk about how to do that later on. So are there any questions about that? Yeah.
Question from online is,
Yeah.
why doesn't node E send to node F instead of node G
Why doesn't node E send to node F?
instead of node G? I suppose it's proximity.
Well, there's a mountain in the way.
He put a mountain in the way.
Yeah, I put a mountain in the way. Yeah, the lines I'm trying to show here are the nodes that actually can talk to each other. There's something in the way. Or maybe it's more, maybe it's further away than I can show it on a slide. Yes, sir. Here, let me give you the mic.
Are all of these radios transmitting on the same frequency? On the same channel then? Okay. And so it's a forwarding thing. So there's a time delay, there's a latency
Yeah.
from one to the next.
Yeah, think of it almost like it was, time slices where, it doesn't, it's a store and forward kind of network. And so, node A sends out the message. Node B and node C receive it. And actually, we'll get into this, but they don't even send it out right away. They actually wait for a second. But we'll talk about that in a minute. But no, so it's a store and forward type network. Okay, Rich has a question. Wait for the mic, please. No, these are good questions.
Don, is node A going to get its own message back again from node B and C?
Yes. But
Oh.
it treats that as an act, because in Meshtastic, in a broadcast message, node A never gets any real confirmation that it ever got wherever maybe it hoped it would get. And if it's a broadcast. So node A will find out from B and C both that, okay, I guess my message got out, but it doesn't find out if node E or node F or node G received the message. It just floats out there.
So in my understanding, they broadcast to everything. There isn't a route pre-configured, right? It's just like, boom, here's a message. Anybody who can pick it up picks it up, right?
Basically, yes. Although in the later version, more recent versions of the Meshtastic firmware, they actually, for direct messages, they do try to build a route when the first message goes out.
Okay.
That's very new. I don't know exactly how it works, but they're sensitive to the fact that, yeah, when nodes start, they can fill up the spectrum pretty quickly. Okay, other question. Okay, we may come back to this. So I'm just going to show all of this because I'm not going to read this slide, but this gets into kind of the weeds of how does the routing work. But there's a couple points in there that are very important. We already talked about it's using a managed flooding algorithm to get the messages out. And we talked about how nodes, when they receive a message, they decrement the hop limit And then if it's not 0, they'll send it out again. Yeah, that get back to your question of, there's times, almost like time slices when each node in the sequence sends it out. And we said the default hop limit is 3. You can go up, I think, as high as 7, but you probably want to think about before you do that, because that could really start bouncing things around. But here, what I want to talk about that's kind of a new concept, and I apologize. I'm going to show you an example of this in a minute. But right in here, we're talking about, let's get into that more detail of how do nodes decide whether they're going to retransmit or not. The one thing they do is they look at the hop limit. But before they retransmit, they wait a period. And that period is called a contention window. And what they're doing is they're listening to see if anybody else sent it out first within that, I'll call it a time slice. Because what they're trying to do with Meshtastic is you want each one of those hops to be as far along, in distance as you can. You don't want 3 hops that are like, all in one city block. Because then if it uses up all of its hops, in a short distance, that message is never going to get very far. So they implement this contention window algorithm where each node looks at the signal strength of the message when it receives it. It's actually looking at the signal to noise ratio. And based on the signal strength or the signal to noise ratio, it calculates what the contention window should be. And the stronger the signal, the longer it waits. Because what it really wants to happen is they want the node further away geographically to be the one that retransmits, because that gives you a bigger reach in your network. Instead of one city block, it could be 15 miles. So each node is going to wait a little bit. There's exceptions to that I'll talk about in a minute. But in general, they delay and they listen to see if there is any other node that in theory was further away that retransmitted it first. And if there was, then they don't send it out. And that way we don't waste hops to get it further out, to expand the size of the network. Did that make any sense at all? Okay, any questions about that? No, okay. So this, like I said, that we go in through all this here, basically that's how you try on, and I don't have an example, with all the different nodes, but that's kind of the idea of how you want to have the widest reach of your mesh network as you can. And that's really important if you're trying to build a community mesh, because you really want to cover as wide an area as you can. If you're like me, I'm not really into the community mesh use case, but I'm interested in hiking in the Adirondacks out of cell phone coverage, and how can I stay in touch with my friends who are backpacking with me, when we're a couple miles off the road. And we're not going to be that far apart, so it's not as important to us. But for a community network, that's really, really important. And let me kind of walk through an example to kind of show what's happened in there. So I made this here, and I tried not to make this any messier than I had to. But in this case, I've drawn this yellow circle and the green circle. The yellow circle is centered on node 0. The green circle is centered on node 2. I'm not an artist, so I really couldn't think of great ways to show that. But what this shows is kind of how far each one of those nodes can get out. So let's kind of talk through again, now talking about contention windows of how this works. So node 0 sends out the message. Node 1 and node 2 both received it. But node 2, the signal strength wasn't as strong. The signal to noise ratio was lower. So it's not going to wait as long as node 1 would wait to retransmit the message. Make sense so far? So node 2 will retransmit it first. Node 1 doesn't retransmit it because it heard node 2 do it. and node 2 retransmits it. Node 0 received it, and then somebody asked, yeah, node 0 is now happy. He says, oh, okay, somebody got it. I'm happy. That's my ACK. But node 2 was also able to get out here to node 3. So that expanded the reach of the network. Make sense? Now, let's talk a different example. Let's assume that node 1 is in the middle of a metal frame building, or it's down in a valley or something like that. So that in reality, it signal to noise ratio, it was lower than node 2. Even though node 2 is further away, node 1, it was a weaker signal. So now node 1 is going to calculate the contention window. It's going to send it out first rather than node 2. That's not really what we want. Because I didn't draw the circle here, but node 1 can't get to node 3. So now, instead of node 2 getting the network out to node 3, node 1 sends it out, and now node 3 never gets it. That becomes very important, again, if you're trying to design a community network, because you really don't want node 1 to be sending them out. And there's ways you can prevent that, and I'll mention them. I'm not going to jump into great detail on it tonight, but there are ways there's things you can do to try to prevent node 1 from doing that. And on the other hand, there's things you can do that with node 1 that you can totally break your network too. But we can talk about those, okay? Any questions about this? No. All right, good. I have no idea what time it is, Jeff, so I assume you're going to keep me honest here, right? All right, so now I'm going to switch gears. I want to talk about preset modes. And this is something that Meshtastic implements that really tries to help somebody who's implementing a mesh network do some trade-offs between bandwidth and data rate and how far can we transmit and that sort of thing. So the default is long fast, and that's a compromise that says if we're in long fast mode, we can build a reasonably large, geographical area network. We can get a kilobit per second data rate, and that's kind of the compromise. If you get a Meshtastic node, and I should mention the first thing you do when you get a node is you have to flash firmware into it. Because these radios can run Meshtastic, they can run LoRaWAN, there's a bunch of things they can do. You'll load and it's going to default to long fast. As you move along, you may decide, oh, I'm building a network that's, I'm just trying to get my city block connected. Well, then you could actually say, I'm going to go to a faster data rate. It's not going to be as large a network, but I can get more data out that way. On the other hand, if you're really trying to build a really extended range network, you might want to switch away from long fast into very long slow. But the reason I mention all this is that it might be very tempting when you get your node to say, well, I'm going to switch it out of long fast into one of these other modes. And you don't want to do that because these modes are not compatible with each other. And that's really why I bring it up. Because they're not compatible. If you switch your node from long fast to say long moderate, you can't talk to anybody who's on long fast now. So don't do that. If you're going to do it in cahoots with everybody else that you want to be able to communicate and build a network with, because otherwise it won't work. For most purposes, you'll probably just leave it in long fast. All right?
Got a question online.
Yeah.
From Robert, can you also speak to the difference between Meshtastic and Mesh Core, specifically how it goes up to 64 hops, but the nodes aren't rebroadcasting, only repeaters resend the message?
I was afraid somebody was going to ask me about
Well, that's
Mesh
why I
Core.
picked it.
And the short answer is I don't really know anything about Mesh Core. I'll say this about it. Mesh Core came after Meshtastic, and Mesh Core, I think, was intended to work on some of the weaknesses and some of the things about Meshtastic that weren't optimal. But as for what's the real differences are and why they did things and how it worked, I really can't comment on that. I'm sorry. It's just not something I've looked into yet. Maybe at later point in the meeting, maybe after the presentation, if somebody in the room wants to talk to that, that'd be fine. But yeah, I can't really talk to it. Yes.
Question on the chart on the fourth column where it says SF/symbols. What does SF stand for?
Thank you. I had to think about that. Yeah, it's spreading factor. And there's probably a radio expert in the room who understands spreading factor better than I do. So if you want more details, I'll hand a microphone maybe. That is not an area I've really researched. Okay. Any other questions? These are all great questions, by the way. Don't be shy. Okay. I want to talk about another characteristic attribute of Meshtastic, and that is channels. And you had mentioned the word channel earlier in your question, and I said, oh, I don't want to say channel because to me a channel is a frequency. Channel 20, channel 21 is a TV frequency, right? And channel 10 is different. I think of channels as, but in Meshtastic, they are not radio frequencies. In Meshtastic, a channel is really a chat room. Think of it as it's a way that you can send information out on the mesh, but you can do it in a way that the random nodes on the network can't really follow you. So that's important because, and I'll get into more channels in a minute, but basically in a given channel, and every node, when you flash your firmware on your node, it comes with, there is one channel implemented, and it's the primary channel. The primary channel is one that every radio has to have a primary channel, and you really would like to have your primary channel to be the same on every radio in your mesh network. And so they default it. And every message in Meshtastic is encrypted, but the primary channel by default always has the same encryption key. And it's right here. It's AQ equals equals. That's the encryption key. So if you want to be able to communicate with everybody else on your network, let's say you're in a community network here in Rochester, and you want to send a broadcast message out that says, oh, there's free water at the fire station. You're going to send it on the primary channel, and you want it to be, don't go in and mess with that. Because if you mess with the encryption key, now nobody else can understand you. But this has nothing to do with frequencies. It's nothing to do, it's just, it gives you an opportunity to create additional channels that are more private for you that still use the mesh infrastructure. Let me jump to the next slide. So there's like, there's like up to eight channels. And so let's say, I'm going to give you an example. Let's say we have a nice mesh network here in Rochester. And the mesh network covers, I live in Fairport, it's covered, and I can within 3 hops get to Henrietta. So let's say my spouse is in Henrietta and I want to send my spouse a message that says, oh, you forgot, this thing, and, be aware of that. But for some reason, I don't want anybody else to be able to, maybe look inside my message. Not that it's easy to do anyway, but I'll set up another channel. I'll set up a secondary channel. Let's say it's the second one. It's index 0 channel 2. And all I have to do is give it a name and a different encryption key. And as long as my spouse and I have that same name and encryption key, we can communicate on that second channel. And it's going to pass, the same mesh network is going to pass all those messages around between us, but they're now a little more private. But we're still getting to use the infrastructure of the community mesh, but we've got more privacy now that nobody else can look in and see what we're saying. Yes.
Is this like an Apple AirTag? Like, is this the same type of thing? Like, how would that compare to like an AirTag? Or
So I'm going to confess that I don't know the answer to that because I don't know much about Apple AirTags. Does anybody else here in the room know the answer? Mike did. Oh, I'm sorry.
Sorry. AirTags talk to iPhones, and then the iPhone talks back to a central server, so it's not quite the same. They don't talk to each other.
Thanks. Okay. Did that answer your question? Good. Thanks, Mike or Jeff. Anyway, you can create multiple. Wait, is there another question? There's a couple other questions. I'm gonna, let's see. We'll let Mike go first.
I'm making a statement. In Buffalo, they have a Western New York Meshtastic key.
They do.
They have their own channel.
Yeah, that's true. I'm not sure what they do with it, but they do have one.
So the routing is all done. The routing for all channels on a single frequency slot is done. Even if an intermediate node can't read the payload, it can still relay it.
Right.
Okay. So
If
it's just the payload that gets encrypted.
Exactly. So if you think of this as a packet of data, there's certain headers and trailers and all that. There's a CRC or whatever. And then there's the data inside, and that's what gets encrypted. So yeah, you got it. Other questions? No. Okay. Cool. Okay. Here. Well, let's yeah, we want all 50 people to hear the question.
I think I'm going to be dumb and stupid.
I was there about a week ago, so don't worry.
So how do you put the message into this little radio to get it out? Do you do it like you have to do a cell phone?
Well, we'll talk about, I'm going to get to that.
Okay. Never
I'm going to
mind
get to
then.
that. Great.
My other,
yeah.
Your wife to get something. How does she know to answer or to listen to the message?
Because she has a node and it's paired by Bluetooth to her phone.
Oh, to her phone.
And she'll get a notification.
Thank
Now,
you.
There are Meshtastic nodes that have keyboards and you don't need a phone, but most of them use a phone. And that's the simple way of thinking it. She'll get a notification. Did that help? Okay. Other questions? Okay, I'll keep going. I have no idea what time it is. Jeff's or somebody's gonna tell me. Okay, we're doing okay. It's only 8:30. Okay. So this is actually going to touch on your question. This is a draw. I don't think you're allowed to give a presentation on Meshtastic without including this diagram. That's a little joke. And this comes from the meshtastic.org website. And the reason I'm showing it is I want to touch on that topic that you brought up a minute ago. Is that this, in this case, we've got these nodes that are out here, and we've got a mesh network, under the hood. They're using LoRa to send the data between nodes. Meshtastic is a higher level protocol that gets from node to node. But to your point, how do you communicate with your radio? Well, if you're lucky, you've got a radio like down here that's got a keyboard. So that's standalone. You don't need anything else. But most of these nodes, like the ones folks held up, at the start of the presentation, don't have a keyboard. So in this case, you're going to communicate usually through Bluetooth. And so, you type your message into your phone, and and then Bluetooth sends it over to the radio with the instruction on what to do with it. And it says send it out. So there's an Android app, it's called Meshtastic. There's a iOS app called Meshtastic. That's, I think, how most people do it. There are some other ways to do it that are kind of shown down here in the corner. If you've got a laptop, there's actually a web interface that you can do in Wi-Fi to your node, or you can even hook it up by a USB cable. And I should mention that if you buy a node, you order one, you put one together, and you say, oh, I got to, flash the firmware onto it. You're going to do it from a computer, and you're probably going to do a USB cable. Because when you get the node, it doesn't have the Meshtastic firmware on it, so it doesn't know about, all the apps and everything. So those are all the different ways that, that's the user experience or the user interface to Meshtastic is really normally through these other devices, unless, of course, you spend some more money and get a keyboard. Okay? That makes sense? All right. So here, that just goes through what I'm saying. Okay. Now we're going to talk about nodes and their role. So I'll start by saying that 90%, 95% or more of all Meshtastic nodes really ought to be configured as a client. That's a general purpose role. You can send messages from a client. You can receive messages from a client. A client will, forward messages, to keep the mesh going. Clients implement contention windows. And that's just a very good general purpose role for a node. But there are other roles. You could, and I got another slide on this, but another role that it could have, just one example, it's called client mute. Client mute can send and receive messages, but it doesn't forward them. So remember we talked about earlier about how you could have a node that kind of disrupted things because it had a low signal to noise ratio when it received, it was inside a metal frame building or something. And so it said, I'm going to send the node because I think I'm further away. And then and then I said, oh, well, node 2 isn't going to send it then. You remember that? Should I go back to that slide? Does everybody remember that? This is where, if you know your node isn't going to have a strong signal from the, from the around, the rest of the world, put it in client mute. Because then it won't retransmit the messages. You can receive them, it can originate them, but it won't resend them. Another example of where you might use client mute, again, because is if you have a node in your car. Now, cars are a Faraday cage, right? And cars are, your antenna is only going to be, this high or something. And so it's probably not going to be the best node in the mesh to reach, to keep forwarding the messages around. And it could cause some disruption there if it decides to send the message out first before a better placed node sends it out. So if you have one in your car, it's not a strict rule. I mean, nobody's going to call the network police on you. And you might have a good reason to leave it in client. I don't know. But if you're just driving around, we used to call it when we were driving around, 30 years ago, and you're looking for open Wi-Fi networks. Not that I ever did this, but it was called war driving. And you drive around looking for open Wi-Fi networks. And if you're out war driving with your Meshtastic node, you may want to leave it and put it in client mute. Similarly, if it's in, an example I live in Fairport. So the Parrington Wegmans is down in a valley. And I got to believe that if there was a Meshtastic node sitting on a car or in a car at the Parrington Wegmans, it could really disrupt things because it's not going to be able to get out very far. So let's talk some more. We'll move to the next slide. I'll talk a little more about this. There's a whole bunch of different roles that you, okay, sorry. Wait for the, I'm like the referee here tonight, you know?
Can a client mute originate a message?
Yes,
It can transmit.
it can originate a message, and it can also be a recipient.
Sure.
And, you know, for direct messages, which I'm not talking too much tonight about direct messages, but they kind of work the same way. But yeah, it can originate, it can receive, it just doesn't forward messages.
Thanks.
Yeah, Nick.
So I'm curious, can you enter and exit a network? So let's say we're here in Rochester and we have our mesh network here,
Yeah,
and then I'm gonna go to Buffalo.
Yeah.
Can I go and I tap into their mesh network
Sure.
there?
Yeah.
Or down to near, no?
yeah, you can.
Okay.
Yeah.
And then let's just say like you said here, you could disrupt the network by not having it in the client mute. If I go to Buffalo and I have it, you know, I forget to switch a setting, will I disrupt the network by?
Maybe it depends.
Okay.
I mean, I don't, like I said, I don't think the network police are going to come after you, but you're probably be okay if you don't think of it. But
And then do you have to, like, for instance, I've seen people that they travel and they bring their node with them.
Yeah.
Do you have to change anything when you go someplace else, or it just,
Nope.
you're in it now?
here's the key. Here's the key to this. Remember we were talking, let me go back. Get to it if I can find it. Not there. Here. Remember we were talking about all these different modes? So the default mode is long fast. But nodes that are in a different mode cannot talk to each other. So let's say, I'm not saying this is true, but let's just say that Buffalo chose not to use long fast. Maybe they said, ooh, we think medium fast is better for our network. You know, they can do whatever they want. If you're in Rochester and you're in long fast, you drive to Buffalo, you may as well not be there, because you won't be able to communicate with any of their medium fast nodes. You won't be forwarding their packets around. And so no, you won't have to worry about disrupting their network because they won't see you. One thing I didn't mention is that each one of these modes works on a slightly different frequency. Meshtastic calls them frequency slots, and there are 104 different frequency slots. The long fast defaults to slot 20, and the other ones default to other ones. I don't know what they are offhand, but that's how they work. So, you know, if you want to be able to talk to other things, you stay in long fast, at least, you know, initially, and don't go in and change the frequency slot. You can go in under the hood and change the frequency slot, and then again, now you're not going to be able to talk to the other nodes unless they all change too. F.
Is there a like repeater book style source of information where you would be able to, oh, I'm going to Buffalo, I want to make sure I'm medium fast?
Not that I know of.
Okay.
There might be.
This sounds like somebody might have.
Maybe somebody has a better answer.
Yeah, so the way I think of it is it's kind of there's a lot of different settings to build your own private net meshes, and you can do a lot of different things if you want. But most people publicly sit on the same settings. So if you don't go in and change from these kind of static defaults, you can talk to most everybody else unless they're groups like you mentioned. You're like hiking. If you want to make yours private, but you don't have to because you're going to be kind of isolated anyway.
That's true.
But so you're not moving around frequencies like you would with radio normally. Just leave it set as how it is, and then you'll be able to talk to most everybody.
Yeah, that's true. I want to mention though that I am aware of some cities out west that have switched from long fast to other settings.
Yeah.
But they're probably, like you say, they're probably the exception.
Yeah, proper communities that want to have like private spaces or something like that, right?
Or they concluded that because of the density of their nodes or the geographic spread or whatever, they said, ooh, long fast is causing us trouble. We're going to switch to a different one and see if that works better. And they found it did.
You can Google search like Buffalo. There's a group in Buffalo.
Yeah.
they have a site and they have information about how like to join their group or join their network
Yeah.
and stuff. And so like in Rochester, I haven't seen a ton of activity, but I'm up in the Seneca Tower sometimes
Mhm.
in Buffalo, and I can see like 40, 50, 60 nodes from like Orchard Park to Tonawanda, like covering all of Buffalo because there's a much more active community. I'd be interested in if there's communities here, but I haven't seen much.
I know a little bit about that, but I can talk about that later.
There was another hand up down here.
So on the Meshtastic website, they have a list of all the groups that have kind of registered with them, said that, hey, we want to be listed on your website. If you're going to a place, you can go check that page, see if said place has any groups that are on that website. And you can go to their website, see if they have any different settings that they have published for you to use. Speaking of Rochester, we have a new group, and we can touch on that more towards the end.
Yeah, there's Rochester's kind of interesting. I think the mesh is still developing here. I think that's the way to say it. Other questions?
Okay, online following up, I guess it may be the same thing, but Sam says meshmap.net will show you which nodes are seen, heard, and on which channel type. Long fast.
Yeah. So mesh. Yeah, it's true. There are websites that have maps of where nodes are. The thing I'll caution you on is that those nodes are ones that wanted to be seen on the map. So I believe, if I understand correctly, they have enabled MQTT so that then they can be seen on the map because the maps all query. If you know more, I'd love you to explain it because I don't know. Again, I haven't enabled MQTT. I'm not interested in working on the over the internet. So
yeah, I can speak to the MQTT stuff a bit more because I've played with that. There's two real settings to know about with MQTT. One is to link your node to that internet server. If you want to do that, that's best done if you have something at home and you want to link it to something far away that you can't get a stable mesh network connection to. There's then another setting in the app, I think it's in the LoRa pane, that's okay to MQTT. That means that you're not connected directly to the MQTT network, but if you're near a node that will forward your nodes over your messages over MQTT. It's off by default. So if they're on this mesh map, they've gone into settings, enabled OK to MQTT, and now they're showing up there.
Yeah. And there's there's good reasons to do that. But I know there's also folks who say, I don't want to have anything to do with it. I'm an off-grid network. And so they don't do that. And so I'm not going to tell you there's a right answer or a wrong answer. They're just, there's different ways to look at it. Okay, so let's talk about a little more about roles. I already mentioned client. That's kind of the default mode. That's probably for 95% of the nodes out there. That's probably what you ought to just stick with, unless you have a good reason to go to a different role. There's a couple that are really, I already mentioned client mute, which is client except it doesn't forward messages. There's also a mode called client base. And client base is really designed that, let's say you've got a node, you've got a ham radio, people talk about everyday carry. Let's say you've got a node that you just carry with you all the time. And you're walking around your house and your node's not getting out very well because it's buried inside your house. You could put a node up on your roof, for example, which is higher, better line of sight, doesn't have all the, infrastructure from your house to block it. And, if you send a message from your everyday carry node, it's going to get up to the house. And client base will treat, in client base nodes, you can favorite other nodes. And if you favorite them, that means that it's going to treat them as, I want to get this, I want to be the one that sends this message out. And a client base will set that contention window to 0. So that means it's always going to be the first one to send it out. And that's the whole point is, you thought about it. You said, yeah, I really want to use my own node, like, up on my tower, if you're a ham radio operator, or up on my roof, you've got a solar power node that's strapped to one of the plumbing, vent, pipes sticking out, or your chimney. And you say, I want to really make sure that gets out. And client base can do that for you. Okay. So I'm only going to cover a couple more here. Another one is called a router. Now, router is behaves kind of like client base. I said, step router always sets the contention window to 0. And so a router is an infrastructure node. They're not going to be, you're not going to originate a message from a router. That sole purpose is to put a node in a very strategic place, such as up on top of a mountain. Maybe around here, maybe you can get it up on Baker Hill, or maybe on one of the towers over at Pinnacle Hill. And it's got a wide view. Line of sight is very distant. You can see the lake. You can see all the way to Bristol or whatever. And if you put that strategic router node up there, it's always going to be the first to resend a packet, or a message when it sees it. And so it basically is jumping in the queue. It's jumping the queue. It's going to be first in line to send it out. And it's going to get ahead of the ones that are getting are weaker and don't have as much spread to send the messages out. Yeah, Nick.
If I have my device in my house,
Yeah.
I have something on my roof. Does
Yeah.
that count as the first hop from
Yeah.
my device to my roof?
That's the first hop.
Okay.
Now if you have a client base, I'm just going to mention this because this is and the internet cannot agree on this. So I actually submitted a ticket to the Meshtastic.org people a couple of days ago to ask about it. If your node is in client base today, if the one on your roof, and it's favorited, the one that's down in your house, it still counts as a hop. But there is a ticket in place to change that. And to not, for those favorited nodes, to not decrement the hop limit. So it said, now that client base node up on your roof is really just an extension of your node. But as of 2 days ago, when I asked them, they said, no, they haven't implemented that yet. So you may see people on the internet talk about that. And I don't know, they might have told me something wrong when I asked the question, but that's what, I submitted a support ticket and that's what they told me. So,
But you can add a hop yourself up to 7.
well, by default it's 3, but you could add, on your node, you could add more hops. Yeah.
Okay. And it's foot or 2 by the way.
Okay, good. Okay. So anyway, that's what a router is. These are very strategic. If you've got a node up on your roof, don't set it in the router. Just leave it as, one of these other ones. Let's leave router to the strategic ones up on top of Pinnacle Hill or whatever. Okay. 2 other types of nodes we haven't talked about much. One of them is a tracker. So APRS, everybody, you know about APRS? People build APRS trackers that they put in their cars or whatever. Well, in Meshtastic, you can have a tracker too. And a tracker has a GPS in it, which a lot of nodes do, but they don't have to. But trackers have a GPS in them, and they are going to prioritize getting GPS position trackers out or position packets out. And so you can use a tracker, like let's say, for example, we're doing public service and we want to know where the sag wagons are, right? Let's put a Meshtastic tracker on there, and then you can keep track of where they are. And it doesn't cost $100. Or you could put them, there's been talk at, I don't see John here tonight, but he mentioned to me that they're thinking about maybe for the Mammoth March this year, putting a couple trackers out just to kind of test and see whether that's helpful for the Mammoth March. So that's an interesting application for Meshtastic that has nothing to do with text. It's sending data around. And then the fourth one I just want to mention is a sensor. So it's sending what they call telemetry packets around. And what's telemetry? Telemetry is just data. Because you can use Meshtastic to send, you can hook a Meshtastic node up to a sensor and then send that information out. So let's say you could hook it up to a weather station that's up, up a mile away and use Meshtastic to send that weather station data back to you. Or you could hook it up to, let's say, you want to monitor, you're inside of an industrial plant and you want to monitor the level of liquid in a tank. You could use Meshtastic to send that around. Or I call it physical security alerts. I make this up. I'm from Indiana. I think of myself still as a farmer. And let's say out in the back 40, you've got a gate and you want to make sure that the gate gets closed every night. Well, you could put a sensor on the gate and a Meshtastic node, and you can monitor to make sure that that your farm workers close the gate at night. So that's a whole nother application that we haven't talked much about. But there's people out there who are putting sensors on these things so that they can monitor environmental or all these types of things. So that's another type of node. There's a bunch more, but I'm not going to get into those. Any questions? Okay. I'm going to switch gear and talk. We're going to start talking about hardware now. And I'm not a hardware expert, although I'm an electrical engineer by education. I'm not an expert on this, but just so everybody knows, there's really two different processors that you can find in Meshtastic nodes. One of them is an ESP32, and this is a fast, fairly fast. It's a 240 megahertz. It supports Wi-Fi and Bluetooth. The most common nodes, which is the Heltec V3, has an ESP32 in it. So they're pretty good for stuff, but it uses a lot of power. And so it's great if you're going to carry it around and you've got a good battery on it, or maybe like I do. I'll show everybody later if you want. I brought one of my hacked up nodes that actually I've got a USB power bank that I hook it up to. It also has a battery in it, but I only hooked it up over the weekend, so I didn't know if it was going to last tonight. But that's an ESP32. They're lower cost, but they do eat battery. The other one is this N52840. I don't have any experience with them, but I understand, they're a slower processor. They don't support Wi-Fi. They do support Bluetooth. But what's more important is it's using less power. So if you were going to build a solar node or buy a solar node and put it up in a high spot where you can't get to it very easily, you probably don't want to use an ESP32 processor. You probably want to buy one of the systems that has, the more power efficient processor. So just, if you're thinking about that, that's kind of one of the main differences in the hardware. Questions about that? Yeah.
Do they both have?
I'm sorry?
Do they both?
Yes. Yeah, they both have LoRa radios in them. Or they're connected, or it's in the board someplace. I don't know if it's built into the processor or not. Okay. Okay, so I'm going to show some examples. These are just ones I picked out. I'm not endorsing any of these. I have some editorial comments to make about them, but the only ones that I have experience with is the Heltec V3. And I have two of them. And you can buy them all over the place now. I priced these from a actual, dealer down in Florida, and they're now up to like $30 if you get it with the case. If you can see that. So you can buy this Heltec, you can buy it. It comes with the main board. It comes with a stubby antenna. Think about your HTs if you're a ham. We often say, well, that's not very good. The stubby antenna on this isn't very good either. But it's something to start with. And it actually comes also with a couple of headers. So it's basically, you can do all sorts of things with this. You can set up sensors and all sorts of things to send that. And it all fits into this nice little case. And I've got one of the cases there, or I saw somebody else earlier had a Heltec V3. Oh, Jeff's got it here. Turn on. Jeff will show you. That's the Heltec V3 in a case. It's a tiny little thing. You can throw that in your back pocket. Did I see a question? Yeah, John.
That stubby antenna connector a UFL, or have they come up with something even smaller?
I I don't know. I don't know. It's a tiny little connector. It's only like this big. I don't know what it's called though. I think maybe he knows. IPX?
IPX connector. That's
Okay. I don't know. I'm kind of, I know about PL 239s. Anyway. No, it's definitely not that's big, as big as the node. But my point is this is one that's been very popular for folks who said, I'm going to go buy my first node. And they've been out for a while, and you can buy them on, they're $30 off at Rack. I forget the website. I listed it later. You can buy these on Amazon. I think they're more like $25 on Amazon. Amazon's not going to give you any support though. And I think if you're brave and you want to go to AliExpress and try to buy something from China right now, I think they're more like $20. So they're around everywhere. Not a bad thing, but if I was going to do it again today, I would not buy this, just so you know. But there's nothing wrong with them.
Sam online, just a note, he says it should be noted that that you need to ensure that you have the antenna connected before powering these things up.
Yeah.
There is a potential that it could emit and basically damage the radio.
Yeah, don't transmit without an antenna. That's a good ham radio rule, right?
Generally speaking.
Yeah, and that's the same thing here. Don't transmit without the antenna. Jeff, almost 9. Okay. This is the Wheel Tracker L1 Pro. They're selling for like $50 now. This one comes, if I was going to buy one today, I might buy I don't know if I'd buy this one, but I'd buy something like this because this one actually comes in a case. It comes with a better antenna, and that's got a battery in it too. Not a big battery, but it comes with a battery, and that's only $50. So by the time, you buy, I bought the Heltec V3, and then I said, oh, I want a better antenna. So then I bought a better antenna. I couldn't use the case anymore. And then I said, oh, I think I want to add GPS to it. I got 2 of these. So one of them, I bought a little GPS module. Well, that costs money too. Or I say, I want to buy a battery. Well, that's going to cost money too. By the time you do all that stuff, if you just want to play around with Meshtastic, something like this seems like a much better deal today than maybe, they weren't as many of these a couple of years ago. So that's another, that kind of, I'm not endorsing this one. I've never played with it, but it seems like a good price, and it's a good example of what nodes are like today. This is a cool little node. It's a Heltec. It's called the Mesh Pocket. And if you kind of look at this, you see this little bump here is where the antenna is. But this is actually a USB power bank that you could use to recharge your cell phone or something like that. But it's also got a Meshtastic node in it. So, let's say you're going, or, let's say you're at let's say you're going to a meeting or something, and, you're going to bring your power bank and you're going to bring your Meshtastic node. Well, wouldn't it be pretty cool if it was all built into one? And I know I first learned about these from, there's the guy on YouTube, Josh Nash, who I forget his YouTube channel, but you know what his YouTube? Yeah, Ham Radio Crash Course. Thank you. He's really big on these types of nodes because now you don't have to have as many things in your pocket.
I know we're running short on time, and I've got a question that's still slightly confusing to me about this. I don't know if you're going to get this, but like you put the app on your phone, and there's not like a login. Like you don't have like a username that exists between the nodes. The nodes themselves start out with some randomized name, right? So if you've got a couple, like you have 2, like I don't know if there's a best practice around like what you name them, if you don't name them at all, and then like if you're carrying one and you swap it for another one, someone can't message you because they message the nodes, not like
they
you as a
message
person.
yeah.
And so that was kind of an area.
Yeah, they don't have
really
you're right. Meshtastic doesn't have a concept of a user. You're messaging nodes, and so if you want to. If you've got multiple nodes, every now and then you want to swap over and connect your phone from one to the other so that you can see what messages are there. I did the bad thing there, and I did that. So I would, if I was going to do it again, I would always send messages just from one of them. and let the other one play infrastructure or whatever. And okay, Nick.
It's like practical use case then. I know we're talking about hardware and we could talk about the technology of all this all day long. All right, everybody's in here is geeked about this right now. Everybody's going to go home and buy a node. What's it like after that? Like, are you getting out there and like, it's not like calling CQ and somebody's going to call back, or if I'm asking
I got a slide that starts to talk about that. Yeah, they actually do.
Okay.
Yeah, it's pretty interesting. We'll talk about that. I've got a few use cases where I'm going to cover that. And I am very aware of the fact that what time it is. Oh, I just wanted to show that this is a LilyGo T-Deck portable. They cost about $100. There's other ones too. This has a keyboard built in. So you don't need a mobile phone anymore once you get it set up. But, one less thing to carry around. Where would you use that? I could imagine, I'm making this up. I'm a parent. When my kids were little, I didn't give them cell phones. I'm like, no, they're going to lose it in a day. And cell phones cost money, but instead of spending a couple $100 for a cell phone to keep in contact with your kids when they're out playing in the neighborhood or whatever, you could buy this for $100 and stay in contact with them with that. And it's just less risk to lose a valuable piece of equipment there. Also, it's less things to carry. So that's something that is really interesting to people. Okay. And this is a 1 watt. This is pretty new. The 1 watt radios are coming out now. This one is $39. It's just, you'll notice it's just the board, the antenna, and the whatever. That one I think has GPS on it too. But this is 1 watt, so get a little more range with that. Just wanted to show that, but it doesn't come with a case. So now you're going to 3D print a case, or you're going to buy a case on Etsy or something like that for it. Get your buddy Jeff to print it for you, I guess. Okay. Use cases. I'm almost done. The biggest use case that I see people talking about is this community mesh. We're going to set up a mesh in Rochester that we can communicate to each other on. There's a lot of people who want to do that right now. There's already one in Buffalo. A lot of cities all over the world have these community meshes. I'm not saying it's a bad idea. I can't really tell you what I think the real everyday use case is for it, but it is something. I mean, some people think, well, we'll use it during an emergency. I can't comment on whether that makes sense or not. Maybe the Aries or Races people can talk about that. But to me, I don't know whether Meshtastic's reliable enough to use it as emergency communications. But on the other hand, you have a community mesh, and I mentioned earlier, you could set up your own private channel and still be able to communicate with, your family, your friends, whatever, without going on the cell phone. So, if you're suspicious of Big Brother, maybe the community mesh, it makes a lot of sense. I'm not judging. I'm just saying I don't have a use case myself for the community mesh. So that's kind of how I look at that. But that is probably the most common use case I hear about. And you'll hear people talk about, online and in the YouTube and all that. I guess. But there's you can create a private channel that uses the published mesh. So, okay, that's cool. But here's another one that I'm more interested in, and that is when you're communicating someplace where you don't have cell phone coverage. I hike in the Adirondacks. You get a couple miles off the road, especially away from the high peaks. Cell phone coverage is really awful. A couple of years ago, I hiked what's known as the Cranberry Lake 50. It's a 50-mile route that goes around to the south of Cranberry Lake. And I can tell you, you get about a mile and a half off the road, you got no cell phone coverage. And you're going to live with that until maybe at one point the trail comes close to the lake and you can get that little 20-foot tall cell tower there. Or maybe you climb Cat Mountain and, now we're getting, our phones went nuts when we did that. But in general, we didn't have cell phone coverage. Now, I wasn't going to use that to communicate to my spouse or my family. but it would be kind of nice to have a fallback that if our group gets separated, which you shouldn't do if you're hiking, but if the group gets separated, maybe you can get back in touch. And I have been on hikes in the high peaks where we did get separated and it got kind of scary. So it's something I think about. So that's a use case. I'm going to try to play with this in a couple months up in the Adirondacks and see whether in practice in the woods it really works very well. Another use case, anyway, you could also, there's a guy, Ham Radio 2.0, Jason. He talked once about how he goes out hunting with his buddies in an area that doesn't have cell phone coverage. And what they do is they put a note up in a tree. And then all the hunters can communicate, you know, with, and I think a lot of them are hams, but they don't want to be talking on the radio. It's going to scare the deer away or something. So instead they're texting around and sending broadcasts out. I'm over here, I'm over there. And they've got a high note up in a tree. And again, that's what they're using it for. So it seems to me that's another, you know, reasonable type use case. Another one that I think about is I go to music festivals, and usually these are out in a field someplace. So there's not really good cell phone infrastructure near that small town. There's one in outside Buffalo. There's the maybe Darien Lake. Yeah, I know. But anyway, you go to these festivals and there's so many people there and they don't have good cell phone infrastructure to accommodate it. And now your phones don't work. Well, Meshtastic would probably still work just fine. So if you need, you know, like if I had little kids and I was going to the festival in East Aurora, it happens once a year, I want to give them some freedom. I'd like to stay in touch with them. So maybe Meshtastic works, you know, good for something like that. And then I also mentioned like trackers and things like that. So you can use, you know, that's a use case that I think there was talk about maybe exploring at the Mammoth March. Rich is looking at me like he really wants me to end this. Okay, so if anybody's interested, these are some places you can buy Meshtastic nodes. There's more, but these are just the three that I identified. Rockland is a retailer. I think they're down in Florida. They sell a lot of different brands, and that's where I bought most of my stuff. They're a little more expensive, but if you got a quiet, that's a real store. So, you know, you can ask, you know, they can probably give you some support. Amazon sells some stuff too, but I don't know. Amazon's not, you know, they're not engineers. So, you know, whatever the seller claimed was good, you know, is that really a 5 dB gain? I don't know. Is that 10 really any good? I don't know. AliExpress is over in China. You can get stuff cheap there. I don't know whether their suppliers are even shipping to the United States right now, but I mention it. And a lot of manufacturers will ship and sell direct to consumers as well. The Rack Wireless is one that gets a lot of attention, and they will sell direct to consumers. They're up in Canada, I think. So those are some places you can buy hardware. Where are we at? And then I got a few links here. If you're interested in the Rochester mesh, there's like 3 or 4 different Discords where people are talking about a Rochester mesh. I picked one, which is they've got a website that then redirects you to the Rock Mesh. Is that you? Oh, well, okay. So that's the one that I there's a lot and everybody up there is really nice. So, and helpful. So you could go there. There's other Discords too. Honestly, I think that's one of the biggest barriers to get in a mesh and really going in Rochester. There's too many different places people are talking about it, but maybe that'll solidify. There's also the main Meshtastic website. So there's a lot of really good documentation up there that explains how Meshtastic works. They talk about hardware, they talk about software, and they've got a firmware flasher right on the website that, you know, you're on your laptop, you hook up a USB cable to your node, and you can flash your firmware right there. You don't have to download an app on your PC or something to flash it. The main Meshtastic Discord server, you can ask questions up there. They've got a million different things going on there. And there's one real cool site if you're into this. There's I'll mention the Meshtastic Site Planner. And that is a really cool site. If you've ever tried to do modeling of radio, you know, radio propagation and things like that, you can go with the you can put in your, your latitude and longitude and the height of your antenna, and it'll understand the terrain and try to tell you how much coverage you're getting. So, if you were at a point where you say, I really want to install a router up on Pinnacle Hill, let's see how much coverage are we really going to get? If it's only, 10 feet off the ground or something. So that's a cool site to go play with, especially if you're just thinking about putting a node up in your second story window or something. Do you really get any reach there? You'll find out. Okay. Okay.
Got Sam KD2WWY. More of a comment than a question. One potential application is setting up a Meshtastic BBS, much like the old school BBS. A couple of projects such as the TC2-BBS-mesh, and he's got a GitHub thing on here, and he's got one of these running at his house. I would make a suggestion to you, Sam, and to anybody else who here is we do have the groups IO on RaRa. Go on the website and click on that. Start a thread on this. And put some of these links and things up there for everybody to look at.
Yeah, I'll post mine up there probably tomorrow or something. But yeah, I knew Sam had I knew he had a BBS. I haven't been able to access it from my notes, so I haven't. Okay, very good. Okay, so now we're doing Q&A. Are there other questions? Anything you were just itching to hear about Meshtastic that I didn't cover? I don't like to buy anything like this from Amazon myself because I don't trust the specs and stuff. John wants to wait. Okay, Tim's first.
So if I'm on a Meshtastic network and I'm communicating from my home in Rush to you in Fairport, what sort of time delay might I expect?
I'm going to look around the room because until 2 days ago, my nodes were isolated. And then somebody put one up over at Whitney Ridge and suddenly, so I don't know yet, but he said it's only a couple seconds.
You mentioned something earlier about ham mode.
Right.
You said you weren't going to talk about it much.
I didn't want to, no. I will talk about ham mode real quick. Okay. I mentioned earlier that we're in Meshtastic today. I think they're looking at some higher frequencies now, but right now it's up in the 900 megahertz ISM band. Now that's shared by, I'll just mention, it's shared by some of the old cordless phones you used to have in your house. I've still got one. That's a 900, and that's in that same band. There's industrial sensors, there's utilities that do remote reading. So there's a lot of different stuff. But the 33 centimeter amateur radio band is in that same frequency range. And so that you can go into your node, and if you want to say I'm a ham, you can go in and enable ham mode. Now why would you do that? I don't know. But one reason you might do it is that now you're a ham and you give it your call sign because it's going to be sending out your call sign with it. But what's really interesting is you can now transmit 10 watts and you can transmit with a higher gain antenna. However, I don't know who you're going to talk to. Yeah. Yeah, you're in the 33 centimeter ham band. And we can go up to 10 watts as amateur radio operators at 33 centimeters. No, I should have mentioned that. It disables encryption when you enter ham mode. Thank you. It disables the encryption because hams can't encrypt. No, it's 900 megahertz. You can look it up on the ARRL, the big band list. 33 centimeters. I don't know if anybody uses it for ham. And honestly, the only thing I've thought of that I might do with this sometime is maybe go out and get a couple other people with nodes and let's go do a POTA activation. As long as we're not on a mesh that's bouncing it around, as long as it's direct, maybe we could do that. I don't think I'm going to do that. But that's what ham mode is. It's not. When you're in ham mode, you can't communicate with any node that's not in ham mode. So in practice, I don't know why you do it, but they do have it in there, and that's what it is.
maybe
Jeff wants
Joe,
me
you
to
could
do-
have the Meshtastic for Pumpkin Patrol.
Yeah.
Yeah, but do the 10-watt ham version, maybe get some connections.
Yeah, we actually tried it at Pumpkin Patrol
Yeah,
this,
that was
this year.
on-
We had two nodes, Joe and I, but we were like 10 miles apart. It didn't work. Plus, I drew a map and I looked at the line of sight, went right over Minden Ponds where the hills are and stuff, so that didn't work. I was going to say, I want to end, but if anybody wants to stick around, and if anybody who brought a node can stick around for a minute, maybe we can gather up here in front or something, and anybody wants to get a closer look at a node. Okay?
Yeah, we were gonna do show and tell. I know some folks brought some equipment that they wanted to show off, and so we were gonna do that over here because some of the guys got to get packing
Okay,
up.
okay. We'll do that over there.
Yeah,
Okay,
so we'll do
that's
that.
great.
Come on over here, and we can do show and tell. And
Yeah.
if you have other questions, etc.,
No.
we can keep going. But some of the guys need to pack up
They
here.
want to pack up, but thank you for coming out tonight for this.
Yeah, thanks a lot,
For
Don.
coming on in Zoom. Great questions. I appreciate the smart people, because we had smart people in the room who knew stuff. So I appreciate, volunteering your knowledge. And I don't know, like you say, we'll send some stuff out on Groups.io. I don't know. I'm going to try to be on the Elmer's Corner this Saturday. And so it's not really ham radio, but maybe if Elmer's Corner starts getting slow, somebody wants to ask about Meshtastic, we can do it there. Yeah, we'll claim it's ham. Okay.
All right, thanks a lot, Don. I really appreciate it. It was a great presentation.